Please rise for the procession. You may kindly resume your seats. Thank you very much. Good evening to you all, and a warm welcome to the Great Hall of Ghana's premier university, the University of Ghana, where we gather to celebrate yet another full professor as he delivers his inaugural lecture. Today's inaugural lecture is the fourth of inaugural lectures scheduled for the 2025-2026 academic year. And today, Professor Yaw Asare Afrane of the Department of Medical Microbiology, University of Ghana Medical School, and Chair of the College of Health Sciences Research Board, will share insights into his many years of research and experience with us. He speaks on the topic, Fighting the Bite, Human Activities and the Changing Landscape of Mosquito-Borne Diseases in Ghana. And I'm happy to announce to you that this lecture is live on the University of Ghana website. So for family and friends who are unable to join us this evening in person, you can share the link with them so they can also benefit from today's lecture. I'll now invite the Registrar, Mrs. Emilia Ej Mensah, to deliver welcome remarks and also introduce to us the Chairperson for this evening's gathering. Please help me welcome her with a round of applause.
Thank you very much, Victoria. Vice-Chancellor, Pro-Vice-Chancellor in charge of Academic and Student Affairs, Provosts and other officials from the University of Ghana, our distinguished lecturer, members of convocation, students, distinguished ladies and gentlemen, a very good evening to you all. And a warm welcome to those of you here in the Great Hall and also those of you joining us online. We are delighted that you are all able to join us for this evening's inaugural lecture to be delivered by Professor Yaw Asare Afrane of the Department of Medical Microbiology of the University of Ghana Medical School. Inaugural lectures are a significant tradition and part of the University of Ghana's calendar, and every academic who rises to the rank of professor is expected to deliver an inaugural lecture. This offers the university the opportunity to recognize and showcase the academic achievements of its faculty and also enables professors to share their research with colleagues within and outside the university and to celebrate this important milestone with their family and friends. I'm pleased to introduce the chairperson for today's inaugural lecture. Our chairperson is the first female vice-chancellor of the University of Ghana. She's a professor of linguistics, an accomplished administrator, and brings over a quarter of a century's worth of experience in the higher education sector. Within the University of Ghana, she's held several key leadership positions, including Pro-Vice-Chancellor for Academic and Student Affairs, founding Dean of the School of Languages, and Head of the Department of Linguistics. As Vice-Chancellor, she's championing the integration of technology across the university's operations while ensuring that people remain at the heart of the university's mission. She has received numerous accolades for her contributions to education, leadership, and the empowerment of women. She's chair of the Council of the Association of Commonwealth Universities, vice chair of the Worldwide Universities Network Partnership Board, and the Association of African Universities Ambassador for Gender Equity and Social Inclusion. She's also the founding president of the African Humanities Association and president of the International Federation for Modern Languages and Literatures. Additionally, she serves as vice chair on the boards of the African Research Universities Alliance and the Worldwide Universities Network. She's a fellow of the Ghana Academy of Arts and Sciences and an active member of many esteemed academic and professional organizations. Ladies and gentlemen, please join me to welcome Professor Nanaba Appiah Amfo, Vice-Chancellor of the University of Ghana and Chair for this evening's lecture.
Thank you, Madam Registrar. Pro-Vice-Chancellor for Academic and Student Affairs, Registrar, Provosts, Deans, Directors, Heads of Departments, our distinguished lecturer, Professor Yaw Asare Afrane, faculty staff and members of convocation, past and present senior officers of the university, alumni and students, family, friends, and associates of the lecturer, specially invited guests from the health sector, the media, invited guests, distinguished ladies and gentlemen, those present here in the Great Hall, and those joining us across various media platforms, good evening. That wasn't very encouraging. Good evening. Thank you. For the fourth time in a row since the beginning of this year, the inaugural lecture platforms have been dedicated to scholars from the University of Ghana Medical School, and I wish to commend the school for producing another professor. The Dean and the Provost deserve some professorial awards. Today we gather to honor Professor Yaw Asare Afrane, an academic from the Department of Medical Microbiology, as he delivers his inaugural lecture titled Fighting the Bite: Human Activities and the Changing Landscape of Mosquito-Borne Disease in Africa. This lecture could not be timelier, particularly with the onset of the rains. Mosquito-borne diseases remain among the most serious public health threats on the continent, with malaria still very prevalent in Ghana, while yellow fever, lymphatic filariasis, dengue, and chikungunya continue to pose significant and emerging risk. The objective of this lecture is to deepen our understanding of the complex relationship between human activity, environmental changes, and the changing behavior of mosquitoes. It draws our attention to the fact that mosquitoes are not merely vectors of disease, but highly adaptive organisms whose breeding, feeding, and survival patterns are increasingly shaped by deforestation, land use change, urban farming, insecticide exposure, and other human-driven environmental modifications. In so doing, the lecture seeks to achieve more than academic reflection. It challenges us to rethink mosquito control beyond conventional indoor insecticide-based approaches and to consider more sustainable, integrated, and context-specific strategies for prevention and control. It also highlights the importance of research evidence in guiding public health interventions, particularly as mosquito populations continue to adapt through insecticide resistance and behavioral shifts such as early biting and outdoor feeding. Now, before Professor Yaw Asare Afrane mounts the podium, I present an abridged form of his profile by way of introducing him. Professor Yaw Asare Afrane is a professor of medical entomology and parasitology at the Department of Medical Microbiology, University of Ghana Medical School, College of Health Sciences. His scholarly contribution to health research is on mosquito ecology and mosquito-borne disease transmission, particularly on malaria. His research has contributed to the shaping of policy on malaria control in Africa. He heads a large research group at the University of Ghana Medical School and is currently chair of the research board at the College of Health Sciences. Professor Yaw Asare Afrane obtained both his O and A levels from Opokuware School. He later earned a Bachelor of Science degree in Biological Sciences and a Master's degree in Medical Entomology, as well as a PhD in Medical Entomology and Parasitology from the Kwame Nkrumah University of Science and Technology, Kumasi. You forgive him for that, since he finally found his way here. Doctoral studies, he continued at the University of California, Irvine, as a postdoctoral fellow specializing in epidemiology and population genetics. Much of his PhD training and postdoctoral research was conducted at the Kenya Medical Research Institute and the International Center of Insect Physiology and Ecology, respectively, both in Kenya. During his postdoctoral fellowship, he was appointed lecturer at the Maseno University School of Public Health. In 2010, he joined the then Bondo University College as a senior lecturer. The institution later became the Jaramogi Oginga Odinga University of Science and Technology, JOST. He was promoted to associate professor in 2013 and subsequently appointed the founding dean of the School of Health Sciences. In 2014, he was named director of research at JOST. In March 2015, Professor Afrane joined the University of Ghana Medical School as an associate professor in the Department of Medical Microbiology. He was promoted to professor in September 2021. Since 2019, Professor Afrane has also served as visiting professor at the University of Pavia, Italy, where he teaches postgraduate courses in vector biology and collaborates with faculty on research initiatives. Professor Afrane has expertise in medical entomology, parasitology, and epidemiology, with research interest centered on vector-borne diseases. Much of his research has focused on mosquito vectors, particularly their ecology, insecticide resistance, and control. In 2023, through the work of his research group, the presence of the invasive malaria vector Anopheles stephensi was documented in Ghana. His team has also reported large-scale invasions of Aedes albopictus, a mosquito species known for transmitting dengue and other arboviruses at Ghana's ports of entry in Accra and Takoradi. This vector has expanded its invasion across Africa and other parts of the world. Professor Afrane's work on mosquito ecology and insecticide resistance has significantly contributed to malaria vector control strategies in Ghana through his collaboration with the National Malaria Elimination Program, where he has contributed technical expertise to guide intervention deployment. Earlier in his career in Kenya, his research contributed to malaria vector surveillance policies in the western Kenyan highlands, where malaria epidemics were emerging as a major public health concern. These contributions demonstrate the direct influence of his research on public health policy and disease control efforts. He is deeply committed to the training and mentorship of young African scientists. Over the course of his career, he has supervised and mentored a number of junior faculty members, postdoctoral fellows, PhD students, and master's students. Professor Afrane has also served as coordinator of postgraduate programs in his home department. He has built a distinguished career marked by an outstanding record in securing competitive research grants and fostering collaboration across the United States, Europe, and Africa. He has successfully led and managed several large-scale multidisciplinary and multi-country research and training initiatives. He currently serves as director of the Center for Vector-Borne Diseases Research. He is also program director for a Gates Foundation-funded initiative aimed at strengthening capacity infectious disease modeling. In addition, he serves as principal investigator on 2 NIH-funded projects examining mosquito ecology and the genetics of insecticide resistance in African malaria vectors. Altogether, he has contributed to securing over 17 million USD in research funding. Professor Afrane has authored 136 peer-reviewed scientific publications with an H-index of 45. He has presented his research at major international conferences. At the University of Ghana, Professor Afrane currently serves as the chair of the research board at the College of Health Sciences, and he's also a member of the board of the Research and Innovation Directorate. In the past, he served on the School of Graduate Studies board. Additionally, he's a member of the academic board of both the university and the College of Health Sciences, and he's contributed to several ad hoc committees within the university. Beyond the university, Professor Yaw Asare is a member of the Vector Control Working Group of the World Health Organization under the Rollback Malaria Partnership. He has previously served as an expert advisor to the Kenya National Malaria Control Program and currently advises Ghana's National Malaria Elimination Program. He also serves as the Ghana Country Ambassador for the Royal Society of Tropical Medicine and Hygiene, UK. In addition, he is a member of the American Society of Tropical Medicine and Hygiene, the American Mosquito Control Association, and the Pan-African Mosquito Control Association. Professor Yaw Asare is married to Dr. Yaw Asare Afrane, and they have 4 children, Yaw, Amanyako, Kwesidako, and Kwekuche. He is a third son of the late Mr. Hayford Che Asare and Mrs. Agnes Wedu Asare. Ladies and gentlemen, it is now my singular honor to invite us all to listen attentively as Professor Yaw Asare Afrane shares his scholarly insights on fighting the bite, human activities, and the changing landscape of mosquito-borne disease in Africa. I am confident that his lecture will enrich our understanding, sharpen our policy responses, and inspire renewed commitment to the fight against mosquito-borne diseases. Enjoy the lecture. Thank you.
Amfo Legon Crotre ni Akwemu Chidom ni Ankobia Framadom ni Okohinesi Obre onwa no nya ho Professor Yaw Asare Afrane, entomologist, parasitologist, College of Health Sciences, University of Ghana. In Nashemo ye baby tie onjuma pa wayama University of Ghana. Any amamine. Yaba mo. Now who's up papi? Who's up papi? We are sent to me in our room. Becky can some penny be assume the antenna supem. Obinfo Yaw Asare Afrane. Ma home swear. Mesro, ma home so. Nenante brebreo. Brebreo. Nante brebre. Brebre. Okodonto.
That was awesome, and I'm very grateful for this Seprewa appellation. Thank you very much. Madam Vice-Chancellor, Professor Nanaba Appiah Amfo, Pro-Vice-Chancellors that are here, Professor Gordon Awandare, the Registrar, Provost, including my own Provost, Professor Alfred Yawson, Deans and Directors, including my Dean of the Medical School, Professor Yvonne Day Adomako, Heads of Department, including my own Head of Department, Professor Japheth Opentan, invited guests who are here who were able to make it, including my cousins who are politicians, former General Secretary of the NPP, John Boadu, and Eric Baidu. priest from my Catholic Church, St. Luke and Sacred Heart, Sister Matilda Quist, invited guests, staff of the University of Ghana and students, ladies and gentlemen, friends of the media who are here. I welcome you today to my inaugural lecture. It's a great honor to stand here before you to give you a very short lecture of a career that has gone beyond 2 decades. I will try my best to be very brief, and I would like to talk about how we fight the bites of mosquitoes. It will not be a long lecture, as I said, and I hope it won't. I would like to take you through mosquitoes that are around us and the disease they transmit, how my career began, how I started to get to this point. I'll talk about the ecology of mosquitoes that I've studied over the years and how we are controlling them, working to control them, and the challenges that are being faced. And then I'll give you the way forward and acknowledge the people who have helped me to get up to this point. So first of all, I would like to thank the Vice-Chancellor that this was not a slot for an inaugural lecture when the calendar was drawn, but the fact that I have been a professor for half a decade, a full professor for half a decade, and I've not done my inaugural lecture, and I appealed to her. She created this day for me, working together with the Director of Public Affairs that I'm very grateful for, and my provost at the College of Health Sciences. I'm very grateful to you for the honor that I've got this day to deliver my inaugural lecture. I don't take it for granted. Now, as we sit here, I can bet you that there won't be any mosquitoes that will bite anyone. I am not a prophet, but that at this time, the mosquitoes that are active biting are called Aedes mosquitoes. They do not bite indoors. They will be outside. And these are the ones that I'm trying to project. If you can see the screens that are around you. The ones to the left. They bite during the day, but they don't like biting indoors. They bite more outdoors. And these are the black and white mosquitoes that normally, if you sit outside of your home to enjoy the beauty of your garden, then they come to disturb you. Their bites are very painful. These are the mosquitoes that we are living with and around us. When the daylight gives off to the night, we experience the Culex mosquitoes and the Anopheles mosquitoes. They bite during the night. And the Culex, for instance, makes a lot of noise in our ears. The Culex is to the right. And in the middle is the Anopheles mosquito, which means business and will come and bite and then leave without having to make so much noise. All these are either biting us for fun because they need blood from us to nourish their eggs and be able to lay the eggs that they have. Even though they have been mated, they cannot lay the eggs without needing proteins from our blood. And that's the reason why they bite us. But in so doing, they can also transmit disease to us. And that is the basis of the work that I've done over the years that I would like to talk to you about today. So there are several mosquitoes in the world, but I'm talking about the one that live around us, bite us as nuisance mosquitoes, and again, who can also give us infection and cause us disease. So the first disease that I'd like to talk to you about, what mosquitoes transmit, is malaria. Everyone here knows malaria, so I don't have to really talk more about it. But the fact is that the last report from the World Health Organization, WHO, for 2025 shows that 5.3 million Ghanaians were diagnosed of malaria. Madam Chair, this is outside the number of people who got sick and either took herbs and never went to a hospital. These are the ones diagnosed in registered health facilities. The ones that went to an over-the-counter pharmacy shop or a chemical shop to buy drugs to cure their ailment are not part of this 5.3 million. Ghana, we are only 30 million, and so this is about 15-16% Ghanaians who were diagnosed. The rest are not registered yet. But the sad thing is that all over the world, in the next few minutes that I will speak, if the program is going to end in the next 1 hour, the WHO estimates that 70 people would have died of malaria within the next 1 hour that we are going to be here. Sad, isn't it? Now, that is not the only disease we have that mosquitoes transmit. And I'd like to expose you to a few more of this mosquito-borne disease that is in my topic. The next one is called lymphatic filariasis. It is transmitted by Anopheles mosquitoes. And when they bite people, they give them a parasite that is called Wuchereria bancrofti. Please don't get confused with that. But what will cause people is that probably in wherever you come from, you've seen people with one leg being bigger than the other. And that is called elephantiasis. And this is caused by this parasite that is transmitted by mosquitoes. It is very common in Ghana, and actually 118 districts are endemic for this disease. But the Ghana Neglected Tropical Disease Program has worked so hard over the years to bring down the disease to a level that is on the path to elimination, and that we can get rid of this disease very soon. It is only left with only 8 districts that are still very high with this disease. And so 110 districts have been cleared. Another disease that I need to mention, some of you may have heard dengue fever. The Ghana Health Service reported in the year 2000, June 2004, that there were outbreaks of dengue in Eastern region and Central region. And at the time, the media space were always talking about this. After some time, it died down. And that is how dengue is. Because it is caused by a virus that is self-healing, if I can put it that way. That our bodies can get rid of the virus. And so many of us here may be infected with the virus, but we are able to recover from it easily. The worst case scenario comes when there are 4 different serotypes, serotype 1, 2, 3, and 4. If you get one serotype and the next time you get another and you heal from it and you get another serotype, that is where complication comes, and it can develop into severe disease. And then that is where death comes. So a few deaths have been reported on this disease, and I hope that we're able to contain it. Last year alone, there were over 2,000 cases, and this is not coming from routine diagnosis from health facilities, but it's from people who are doing research like me, who find these diseases and report to the Ghana Health Service. And that is how they got over 2,000. So if we're actually to measure this disease, then it is going to be more than this amount of the number that I'm mentioning now. There are many more mosquito-borne disease in the world, but I don't want to talk a lot about them for time's sake. But those of you who read news a lot, in 2024, there was an outbreak of a virus called Oripauchi in the Americas. It spread so quickly, transmitted by the Culex mosquito. And over 12,000 people got sick of this disease with some deaths. And so mosquito-borne diseases are very many in this world. There is chikungunya virus, there is yellow fever, Red Valley fever, and then West Nile virus. Some of these yellow fever, I know that many of you here knows about it because it's sporadically, outbreaks of this occurs in Ghana somehow sporadically. So this is the mosquitoes that I'm going to talk about and the work that I have done with them over the years. How did I start this career to get here? I actually didn't want to work with mosquitoes at the beginning. But when I got an appointment as a research assistant at the Kumasi Center for Collaborative Research in Tropical Medicine, as the Vice-Chancellor said in my profile, in 2001, I went there because I've had a job. And I happened to work with people who thought about my development. And at the time, the director of the center was a German called Dr. Thomas Krupa. And he encouraged me not to take this path, which is less trodden, because in Ghana there were at the time not medical, but a lot of people who have studied medical entomology and studied mosquitoes. And there were less than 5 people. So he said, this is an area that I find Ghanaians not interested, so I would like you to follow this path. He gave me opportunities to attend workshops, to develop my capacity, such that I fell in love with research. And together with Professor Kofi Owusu-Deku, who was my lecturer at the Department of then Biological Sciences, now it's called Theoretical and Applied Biology, I got interested in pursuing a career in research. I thank these 2 gentlemen. I would not want to put them to the acknowledgement level, because they did a lot for me during this time. Somebody who had just finished school and were able to create a condition for me to be able to start a career in health research. And so I started learning the basics for research at the KCCR at the time. And as you can see in the middle picture, this is the late Professor of GAMS, who used to visit Ghana from Germany to give us skills in medical entomology. And in my profile, I said I pursued a master's degree. Now, during this time, I was given a research project to do. Now, a study at the time from the Institute of Water Management at the time showed that many of the vegetables that was consumed within cities like Accra, Kumasi, and Takoradi are actually produced or cultivated within the city, not from the rural areas. And these are areas that are within the city that are low-lying, and people take advantage to produce them, not just at the backyard of their homes, but they have these farms that are littered. And all this have informal irrigation that serves to create the opportunity for farmers to be able to utilize this. The advantage was that it was creating food security in cities, and it was giving livelihoods to people who were doing this farming. However, what was happening was that this informal irrigation were providing opportunities for mosquitoes to breed. And therefore, this was a basics that we need to look into. How much these irrigation schemes are creating opportunities for mosquitoes to transmit malaria within the city. So this is the work that I was given to do as my first ever research. And so I worked to collect mosquitoes in the areas around these farms. And let me tell you, those of you who are familiar with Kumasi, if you look at Jinyase, an area that borders KNUST, between KNUST and the Jinyase market, there's an expanse area where people do this kind of cultivation. Also, if you are familiar with Ayeduase, also next to on the eastern side of KNUST, around some of the hostels, there are big farms where these farms can be found. At the time, there were also some of the farms around the airport area. I think there are no more there. But then also, if you are from the Tech Police Station, if you are moving to CCC Church, somewhere there were also farms there. So I chose this site and always visited the area to collect mosquitoes, look at the density of the mosquitoes around those areas compared to the areas where there were no agriculture, and to compare also with the peri-urban areas. Now, and then look for infection within the mosquitoes using skills that I had learned from my work with the KCCR. Now, in short, from this finding, we saw that there were most of the mosquitoes that were at a time moving around in Kumasi were actually coming from these urban agriculture areas. And many of them were infected. And many of the people around there had had reported in the last 3 months episodes of malaria during this time. And so I was lucky to get a publication, a research publication from that. And at that age and at that exposure, it really ignited me to start a career in health research. It didn't end there, but the people that I just acknowledged, Professor Dr. Thomas Krupa, they gave me the chance to go and present this work in a conference in Tanzania in 2002. This is the Multilateral Initiative on Malaria, the biggest conference in malaria. And when I went there as a young, up-and-coming research assistant, I presented my work, and then later on, a certain gentleman talked to me about what I presented, and told me, would you want to do your PhD? I can give you a scholarship. And this was wonderful. And so there came Professor Guyan, who has logged in and is listening online from Irvine, California. He gave me the chance to do my PhD. He gave me my scholarship, a scholarship to study for my PhD during this time, just for presenting my work at the meeting. And Madam Chair, one thing that I'd like you to know is that day was wonderful, and that meeting was just wonderful, because your Prof Vice-Chancellor, Professor Gordon Awandare, sitting here, I got to know from his inaugural that he also got a scholarship the same day. Professor Gordon Awandare got a scholarship the same day. Madam Chair, it didn't end there. There is Professor Anita Gansa at the Noguchi Memorial Institute for Medical Research, also a faculty in this university. She also got her scholarship to do PhD the same day. I will not triplets. It was a wonderful time for us, isn't it? So now, I got a chance to do my PhD, but it wasn't from University of California, but as is reported, I got it from Kenya University finally. Now, but I was sent to go and collect my data from Kenya. And so I went to stay in Kenya. I started working with the Kenya Medical Research Institute to collect data on mosquitoes and malaria transmission, to be able to graduate with a PhD in medical entomology and parasitology. Now, when I went to Kenya, something fascinating happened. Was happening at the time. In Ghana, at the time, if you go to the hospitals, those of you who are medic here, including my dear wife, Ajwa, at the time, severe cases of malaria was happening only in under 5s, children who were 5 years and below, or maybe 10 years and below. But when I went to Kenya, older people like us sitting here could get severe malaria and die. Why in Ghana, younger people were getting is that they have not yet developed immunity for malaria. Many of us have been exposed to malaria since we were born, and so we may even having the parasite in us at this time. However, we may not even know and we recover because we have immunity, functional immunity to kill the parasite. But those people who are living in the highlands of Western Kenya have never been exposed to malaria. And so they have not been able to build immunity. And so older people are getting malaria for the first time, and they will get severe disease and die. And it was shocking. And so even in the newspaper, I saw they reported that there are epidemics of malaria in this place. And I was very shocked. And so several reasons were given for this phenomenon that was happening. First, people were talking about the fact that it is drug resistance, because at the time, the choice for treatment of malaria was chloroquine. And I hope that many of you here remember that we used to take chloroquine when we get malaria many years ago. We've stopped. We've moved on to other medication now. It's a combination therapy. And so they thought, okay, let's change the drugs because it is the chloroquine that has become resistant and people are getting it and dying. Others were also saying, oh, mosquitoes have come to the highland areas because of climate change. And when I do talk about the highland areas, these are high elevation areas that are over 1,500 meters above sea level. higher than high areas in Ghana like the Volta region and Kwawu area or Ebri area. It's much far higher than that. These places are around 600 meters above sea level. So if I'm talking about 1,500 meters and above, that is really an area where mosquitoes, it's very cold for mosquitoes to develop. Now, so people were attributing to climate change. Others were also saying this is drought resistant and giving different reasons. But then one thing that people had not looked into was that the area has become permissive because they were cutting down the forest in these high altitude areas. And so my work was cut out when I went, that I was supposed to look at how environmental changes, including deforestation or land use changes, were contributing to the malaria epidemics that were happening in the highlands of Western Kenya. Ladies and gentlemen, so over there at the time, the forests were being depleted to make room for either housing or housing development or for agriculture to feed the increasing population within Kenya. And so they were cutting down the forest. At the same time, you see that they also had areas where there were swamps. These swamps do not support the growth of mosquitoes. Mosquitoes cannot grow. But when they clear the water, then when they clear the swamps, water becomes exposed and mosquitoes can then breed in there. When they cut down the forest, it opens up the forest, and when it rains, water collects, and so mosquitoes are able to breed. And then again, studies from, especially in the Amazon forest, which has also been depleted, showed that cutting down the forest also increases the temperature. Now, mosquitoes are small animals that cannot produce their own heat, but they have to rely on the heat that is in the environment. For us, right now the weather in Accra has changed a little bit, and you see people wearing sweaters around. We are able to generate our own temperatures to survive. But mosquitoes, if it become too cold for them, they will die, or they are not able to develop. And so then cutting down the forest is creating the opportunity for mosquitoes to breed and proliferate in those areas. And these areas are where the whites in the people from Europe who occupied, the settlers from Europe who occupied the place, lived and also were clearing the land for their farms. And so all of this were making the soil open for mosquitoes to breed. So my work there at the time was to measure the temperatures in houses and outdoor places to look at how the mosquitoes, the number of days they take to develop within these areas, mosquito development and their survival. I also look at how often they would bite humans around there. This is complex to your ears, and I don't want to take you through that. But again, how long do they take to also develop the malaria parasite? And if that is possible, how long does it take for them to develop? So in modeling all this, putting all of this data together, I came to the conclusion that the forest, when the forest is cut down, there's about 2 degrees Celsius temperature difference between the forest areas and the places where the deforested areas where people are living. It's not just a forest, the forest within it, there are homes. But where they've cut it and cleared the forest and people are living there, the temperature difference was 2 degrees Celsius. And this was biologically significant to cause the mosquitoes to develop better in the deforested areas compared to the forested areas. And so this was one of the reasons that was contributing to the epidemics in Western Kenya. This was very significant because such a study had not been done in East Africa, where they live on top of the hills. And in East Africa, when I talk about East Africa, I'm talking about Kenya, Tanzania, Ethiopia, where the altitude is very high. Now, from there, I did several studies looking at mosquito ecology, and my profile has been read, working with different organizations and universities. But then I transitioned to come to Ghana to live here when a lady sitting here convinced me that we are better off living together. And so come down, let's start a family. And that is how I came down, and I got an appointment with the University of Ghana in 2015. And so with funding from the funders that I'll acknowledge later, I started studying mosquito ecology in Ghana. And my studies have taken me through the plains of Adan in Greater Accra region, through the forest of the eastern region in high altitude areas like Abetifi, and the Volta, Mejofe in the Volta region, into the savanna areas of northern Ghana. And so I always study within different ecological landscape to understand the binomics of mosquitoes and the disease that they are transmitting. And so every season, which is the dry season or the rainy season, I would go out there and study mosquitoes, collect them, look at the infection rates within them, and then also screen school children as a proxy for determining the malaria endemicity in the area, so that I can provide this data to the Ghana National Malaria Elimination Program. I'm glad to say that in 2022, Ghana launched a malaria elimination program because now some of the districts, the malaria situation has gone down due to the interventions that have been put in place by the Ghana Health Service. So we launched an agenda that by 2030, we should get rid of malaria in Ghana. We should try to eliminate malaria in most of the districts in Ghana. And I'm happy that I'm part of this all-important program that is ongoing. And so my research group based at the University of Ghana have done a lot of work looking at the mosquito ecology, looking at where they breed. And I would like to say that so far, mosquitoes don't breed, as I'm talking about the forest of Western Kenya, people live in there. But in Ghana here, they don't breed in the forest and come to our homes to bite. They breed around us, in puddles that are formed around our houses when it rains, in drainage ditches that are constantly there. We walk by them every day, and we don't bother to look into them. And so these are the human activities that I'm talking in my title when I said that fighting the bite, human activities, and mosquito-borne diseases. From the beginning, when I started talking about my work that I did, my early stages, it's all human activity. Creating dugout wells to be able to do irrigation, to produce vegetables, is all about human activities. In the Western Kenya highlands, cutting down the trees is all human activities. And then around us, we dig trenches, rain collects in, we walk by, we don't do anything about it. And then these mosquitoes fly into our homes and bite us. Even when we want to enjoy the beauty of our gardens, they tell us, leave. If you don't leave, we are going to bite you here. And we go in. Even then, others are waiting for us there. So there are different mosquitoes that I've talked about. And some of them breed in car tires, especially car tires. These are Aedes mosquitoes. And these are human activities that we leave the car tires. We don't need them anymore. After some time, the car tires on our vehicles get worn out, and then we decide to leave them anywhere, and water collects in them. This creates a warm environment for these mosquitoes to breed. There are also tins and cans and buckets that are broken that we leave them around our neighborhood. That mosquitoes water collects in, and at this time it's raining, heavy rain almost every day in across Ghana. And so water collects in this. And this is where studies from my research group that are sitting here have found that mosquitoes are breeding in all of this. Those of us who are rich enough to have air conditioners at home, sometimes you have to collect the air condition water coming from it. Otherwise, they mess up the whole place. If you go in there, that's where we find a lot of mosquitoes that are breeding to come around our houses to bite us and to be able and to transmit disease onto us. Now, where do these mosquitoes hide? Sometimes we think that we have sprayed the house and so they are not there. They are just around our houses, outside, and we go out there to collect them. They are also hiding under our beds, under tables. When they bite us, they take some time to digest their blood before they go out to look for a place to lay their eggs. They also hide in the hedges around our homes. It's always nice to put hedges around our homes. I'm not saying don't put hedges, but let's always cut it so that it doesn't become a place for mosquitoes to hide, to bite us. Now, I've been saying that I've been collecting mosquitoes indoors, outdoors, in these places. How do we collect the mosquitoes? We have different ways of catching them. And some of them include what is called a Poco Pack. You see that mosquitoes could be hiding up there where we are sitting. And this gadget will help that there's a long tail to it that we can stretch it to go up there, suck everything that is there, all insect that is in there, and later on we go and put them in our insectary and then be able to take out the mosquitoes that we are looking for. Sometimes we go out there, make ourselves as bait because mosquitoes want to use us to come and bite us. Our bodies have warmth that allows the mosquitoes to get closer to us to bite us. And in so doing, we'll be able to catch them. Mosquitoes rely on the carbon dioxide that we breathe out, our body temperature, to get closer to us. And so sometimes some people have, and also body odor. And the body odor depends on who. Some people have much more intense body odor than others. And so they get more attracted to mosquitoes than other people. And so we rely on such people to collect our mosquitoes. Madam Chair, it's not only humans that we use, but also we have other gadgets that is called Biogen Sentinel traps, which also we create our own carbon dioxide by mixing yeast and sugar and water that will produce carbon dioxide, and then the mosquitoes will get attracted to come and bite. We are not always using humans. And sometimes we also set light traps because insects in general would hover around light sometimes, especially the younger ones. And so we use this method to collect the mosquitoes. Again, we go out there everywhere, walking around homes, because we know that is where mosquitoes would breed, and collect where the drains and ditches around us. And I'm sorry to say that sometimes during the dry season, when people store water in their homes, mosquitoes get there to lay their eggs and start breeding and come to bite us in our homes. And so we've done this collection of mosquitoes across Ghana in the size that I just showed you. And let me say something that I have seen from our studies here. We've worked in places like Amfo, and that has valleys that are shaped like a V, the letter V. And so when it rains, most of the the water gets drained off. And it's also high altitude areas, very cold. Mosquitoes are not able to develop a lot there. So in the whole season, we may collect only 6 mosquitoes, if you're lucky. That's the maximum we've ever collected. But if you look at Adafon, where the land is very flat, then going out there to collect mosquitoes, the mosquitoes are breeding almost everywhere. And there are farms also there where they are using irrigation. And so this provides opportunities for mosquitoes to breed. So the climate where we live also contributes a lot to the proliferation of mosquitoes in those areas. And so I'm not saying that people should live here and all go to live in Amfo. But one of the things that I'll emphasize later on is that if the climate is breached, then probably mosquitoes could move from low-lying areas like Adan, the plains of Adan, into such areas like Abetifi, like Amfo that are on high altitude areas. Now, recently, I met an old guy, and this guy really made me think that when I said that I was going to have an inaugural lecture, I said, wow, You still have been collecting mosquitoes. And it's been over 20 years since he's known me collecting mosquitoes around Kumasi area. And he said, why are we not looking for any solution to these problems? Well, there are solutions that are ongoing in Ghana and elsewhere in Africa to control mosquitoes. And so let me tell you that bed nets are being distributed all over Ghana. And people collect these. The coverage is around 70% of people who collect the bed nets. But their usage is around 35 to 40%. Not everyone who picks it sleeps under them. That's the unfortunate part of it. And in the cities of Accra, Kumasi, and Takoradi, figures from the National Malaria Elimination Program shows that fewer people even take the bed nets and they don't even sleep under them. We think that there's a perception that it is warm and inconvenient sleeping under them. But they could protect against mosquito bites and help bring down disease. I'm happy to say that if I was to give this talk 10 years ago, I would have talked about over 12 million people getting malaria. But right now, malaria has gone down so much because of these interventions. Another one is that in some districts, especially in the north of Ghana, the National Malaria Control Program, through the Presidential Malaria Initiative of the United States of America, do spray homes and around homes of many places in northern Ghana. This is called indoor residual spraying. And this is where lots of people are trained to do the spraying, and they are put in buses from the regional or the district capitals, and they drive them into these areas, distribute them to spray all the houses in the villages. And coverage, most times, not less than 80% of the houses are sprayed. So sometimes they could go up to 90, 95%. But not everyone wants their houses to be sprayed. Let me say that. And so this has been effective in bringing down malaria in those areas and killing mosquitoes. Now, another one that is being done by a company in Ghana that is common to most of you, Zoom Lion, is that they've been mandated to do larviciding, looking for where the mosquitoes are breeding and putting a bacteria formulation. It's not an insecticide. It's not a chemical insecticide. It's a bacteria formulation that has been developed that they put into those water bodies so that if there are mosquitoes breeding there, they should be killed. They also do this in selected districts in Ghana. To complement this, I know that most of you here also use other means. Some burn herbs. I know that orange peels also, if you burn it, you dry it and burn it, the scent that comes out kills or drives mosquitoes away. But most of us, including myself, will put a repellent in the front door so that mosquitoes will be repelled and they move out. Also, before you leave the house or when you get in, you want to spray the houses with aerosol sprays. And this is called space spraying. Many of us here may be practicing this. This is very effective. And all this have contributed to killing mosquitoes and bringing them down. But why do we still have malaria? That's the biggest question. And we got over 5 million cases last year. There are several challenges of mosquito control, and I would like to expose a few of them to you. Now, the biggest one of them is that there are all these methods that we are using to kill them are insecticide based, and these mosquitoes are smart enough to find a way to evade the insecticide that are being used. So they become tolerant to the toxicant, the insecticide that is being used. And therefore, they have tried to develop various mechanisms to evade this so that when the mosquitoes receive any of this insecticide, they produce an enzyme that destroy or detoxify the insecticide that has been sprayed on them. And therefore, as you see in this photo, a mosquito is sitting on a net that is treated with an insecticide. All the bed nets that are being distributed are treated with an insecticide. And depending on where you live, you receive different form of the insecticide so that this resistance will go down. However, they are smart enough. They breed very quickly, and so they have developed these mutations that will become like a gene to be able to outsmart the insecticide that is being used on them. And this has become one of the strengths of my research group, that we've published several papers that has helped to identify, contributed to the knowledge of where insecticide resistance in Ghana is so high or low, so that different bird nets are distributed to these communities to be able to kill mosquitoes and break down mosquito-borne diseases. Now, it is not only the insecticide that we are using to kill them that they have become, that has made them to become tolerant. But you see, there's a lot of mosquito breeding in these agricultural areas that I've talked about. Farmers who want to kill the pests that are destroying their crops. And so they also use pesticides or other forms of insecticide to be able to kill the pest. But then this washed into the nearby water where mosquitoes are breeding. And so right from the time that they are immature, before they become adults to come and bite us, they've been exposed to some form of insecticide or pesticide. And so they start building this tolerance to the insecticide. So as adults, when you spray your room, you feel that you want to sleep well, you live for 15 minutes, you come back, you sleep, but in the middle of the night, you find that, how did the mosquitoes get in? They just got knocked down. And so we have something called a knockdown resistance. They got knocked down, and later on, they will recover and start flying and coming to bite. And that is the bad aspect. And I'm hoping that a few of you have seen that. Sometimes when you are burning a coil, and you're going to check whether the coil is actually burning, you go and the mosquito is actually sitting on the coil. Have you ever seen that before? Okay, it happens in a few times. And the mosquitoes are fascinated by, what is this thing burning? And then they, because they can smell the aroma of the coil, but they will not die because they have developed tolerance to this insecticide that is in the coil. Now, this is making the mosquitoes to adapt in several forms to the bites, to when they bite. So sometimes, because they know we are under bed net, sometimes they don't come early to bite us. They come around 5 o'clock when we are woken up. And that is where we receive a lot of bites. So there's a graph here that I'm showing you about one of work done by my research group, that when we start catching mosquitoes around 6 p.m., around this time, and then by the time that we are ready to stop, that is where the population has really peaked. And then we don't know whether to leave or to stay to collect more. And so they are adapting their behavior. And this is one of the challenges, adaptation, mosquito adaptation, that is causing disease to increase. Another one is the invasive species that are also coming into our countries. And so we reported a few years ago this Anopheles stephensi and Aedes albopictus that they have invaded Ghana. Now, this Anopheles stephensi is a mosquito that is originally from Asia. They are not part of the mosquitoes that when we were growing up, they were here. And they have invaded East Africa and caused a lot of epidemics in Djibouti, Eritrea, and Ethiopia. Now, in 2022, my research group, 2022-2023, we found them in Ghana and reported to the WHO through the Ghana Health Service. And a lot of work is being done, so we are not even finding them anymore. And then this Aedes albopictus is the one that transmits dengue. We found them in 2023. And by 2024, the Ghana Health Service has started to talk about, to report outbreaks of dengue. We don't know whether they brought it or not. And so these are big issues, invasive species that are not native to Ghana, but they are coming in. Now, because of this, my research group has been going to the ports, Tema and Takoradi, get permission to look into the containers that are coming from ships, that are coming from elsewhere. And we found a lot of them of these, and we have reported all of them. First, reporting to the ports to know that this is what is happening. Mosquitoes are coming from elsewhere, which could increase the mosquito-borne disease in Ghana. Again, through funding and help from the National Institute of Health of the US, we did a study together in Agogo and Wenchi, where we hung a helium balloon. I'm showing this in the photo. A helium balloon about 12 meters wide, very big, about 400 meters from the ground. And then at every 50 meters, we put a panel of nets there that is sticky. So any flying insect will be caught in it. And we were shocked to know that at that height, mosquitoes are flying. Whether they're being blown by the wind that were caught or they actually migrate like birds is another story that we are still working on to find out. But we did this study in Agogo, in the Ashanti region, and Wenchi in the Bono region of Ghana. And so these are ways that mosquitoes can be flying from elsewhere, not only from the ports, that are a challenge to mosquito control in Ghana. Now, another one, recently, this is something I just took from BBC. They reported that Iceland, and if you hear the name, if you've never been there like myself, Iceland is a place that is very cold, I hear. And mosquitoes were not there. But since last year, 2025, August, mosquitoes have invaded Iceland. And this is where I say that if we allow the environment to be permissive, then the high altitude areas of Ghana, like Amfo, like Abetifi or the Kwewu mountains, will be inhabited by mosquitoes that transmit a lot of disease. Madam Chair, this is the issue that I have been researching on for since I became a researcher a few decades back. Is there any hope? Or this is going to continue? Before we were born, there were mosquitoes. And after we have been born and we've been growing, mosquitoes are still there. Is there any hope? Yes, there is a lot of hope. There are new control methods that are coming up and which will be rolled. Not only the bed nets and the spraying that I've talked about, but there's something called spatial repellents. This is something you put in front of your house, and it repels mosquitoes. This has been tested in Zambia, Kenya, and Mali, and it's been shown that they really repel mosquitoes. And I'm glad to report that very soon we start studies here in collaboration with the National Malaria Elimination Program to roll this out in selected districts to see how this would be able to bring down mosquito numbers. Another one is that there are drugs that we take as humans, which we've been taking for many years, that makes our blood to become poisonous to mosquitoes. And so when we take these drugs, either we give it to animals or we ourselves take it, and can be taken by animals or humans, then our bodies become poisonous. Our blood becomes poisonous to mosquitoes. When they do bite us, they go out there and die. Okay, so these are also new drugs that are going to be tested. Another one that I'm happy to say also that we started discussion with our partners elsewhere to bring this to Ghana, if possible, and it's been done elsewhere, is that we find a way to sterilize the male of the mosquito. The male of the mosquito, please, let me repeat that. And so when we sterilize them, their sperms become weak and will not be able to fertilize the females when they mate. Fortunately for mosquitoes, the female only mates once in their lifetime. And so when they mate, they don't mate again. Their genitalia is closed forever. And so that means that the sperms that they will get to nourish their, to fertilize their eggs are all fake. And they would not be able to produce any genuine offspring. And so they grow and then die, and the mosquitoes will be wiped out. Let me tell you a few success stories also that will encourage you that mosquito elimination is possible. Many years ago in Brazil, our own mosquitoes, the Anopheles gambiae, invaded Brazil. And then this is 1938. They used environmental management, clearing bushes, clearing where mosquitoes are breeding around our homes. The photos that I showed, I am sure that in your neighborhood where you live, You walk past some of those. You drive by some of those. Those are the people what they covered to try to remove all those things. And in 2 years, just 2 years, all these mosquitoes were eliminated, and they brought down malaria transmission in Brazil. And so that is very possible. Another one is in New York. And when I talk about that, there were mosquitoes that were causing disease in New York. Some of you would think that those of you know New York, that where were they breeding? They were breeding right there. But they also use environmental management, which we are not using in Ghana now, to bring down the mosquito population so that people can be free of mosquito-borne diseases. And again, as many people get rich, they put nets around their homes. They create conditions in their house that mosquitoes will not be able to get in. And so all this help mosquitoes to be eliminated from the United States, including Florida. And Madam Chair, in 2022, I was privileged to be in Florida under a program sponsored by the Gates Foundation to look at how they've historically been able to control mosquitoes. All the marshes that were there that were producing mosquitoes, they made sure that they create channels for the water to move. Mosquitoes don't breed in rivers or flowing waters. They actually breed in stagnant waters. And so if you make the water to move, then we bring down mosquito breeding in those areas. And so this is possible. And as I get to the end of my lecture, what is the way forward? What should we do to make mosquitoes bring down, to control mosquitoes and eliminate the disease they cause? Fighting the bite of mosquitoes is not an easy thing, and I will not say that it's going to be very easy. But this requires collective effort from you and I, that in our communities, we should work to, when we walk around our homes, we should get rid of all the water that are being collected, either in cans, in tins, in car tires, in the puddles, and drainage ditches, the ditches that are formed. We get rid of all of this, and then these mosquitoes will not breed and come to bite us and give us disease. Again, when I was growing up, like some of you, there was this system where the town council or the municipal council will have people who are smartly dressed to come. And if they find that you have not cleared your environment, depending on where you come from, they were calling them town council tankers. They will have a grudge with you, and they can even take you to the local court that you have not cleared the bushes around your homes. You have not gotten rid of the breeding habitats for mosquitoes. If you should bring this back, that would be wonderful, to get rid of mosquitoes that are being bred in our homes. Again, another thing that I will want to emphasize is that when we are developing new areas, we should make sure that we allow public health practitioners to be part of the planning, the urban planning or the rural planning. And so you go to some places in Accra where are new sites, not only in Accra, all over Ghana, big towns that are developing into municipalities. This one's bedroom faces this one's kitchen. This one's kitchen faces this one toilet, and all that. And so they create conditions for water to collect in those areas and allow mosquitoes to breed in those areas. And this is one of the reasons why the mosquito-borne disease still persists in our environment. And again, let me emphasize that we need to train more people, especially people who have the expertise in mosquitoes, mosquito research, mosquito control. When I started, there were very few people who were doing entomology. And right now, we've been able to train a lot of people. And as I go to the end of my talk, I'd like to emphasize, Madam Chair, that one of my strengths of my research is that I train the next generation who will take over from me. And so I have been able to build capacity. Thank you. I've been able to develop the capacity of some of my colleagues and who are also sitting here with me as faculty, and other people sitting over there who are also people that are exposed to research and development. And they get a chance to move elsewhere, not only in Ghana, but go to other countries, especially in Europe and America, to be able to develop and hone their skills in research so that they can contribute into getting rid of mosquitoes and bringing down mosquito-borne disease. And as I end, I would like to tell, this is my take-home message. The mosquitoes that are breeding around us and biting us every day are not coming from the forest and anywhere. They are bred within our own areas. They are bred around our homes and sometimes within the house itself. And they come to bite us, giving us a lot of nuisance. If they are not even giving us any disease, there's a lot of nuisance. They make a lot of noise in our ears, disturbing our sleep. But then again, they also carry pathogens that can cause disease in us. And so the answer to this is also within us. We also spray a lot of times, uncontrolled spraying around our homes and then inside the homes with aerosol sprays. That makes them stronger and fortified to escape the toxicant that we are using. And so if we bring this down a little bit, that would be wonderful. And so it is we humans who have created opportunity through our activities for mosquitoes to breed around us, to bite us, and to cause disease. And if we should reverse all this in the ways that I've talked about, then we can be able to eliminate mosquito-borne disease around us. Thank you very much. Thank you. I've not worked alone, and so I'd like to take just a few minutes to acknowledge the people and opportunities that have come my way and the organizations that have helped me to get to this far. And so I would like to acknowledge my trainees who have helped me to be able to work a lot and be able to work to be able to cover a lot of things that I've done and publish so much to become a professor of international repute, if I should put it that way. I thank you, my trainees, my colleagues who are what is called junior faculty, who recently got appointed in the university, who needed opportunity to get also scholarship and all that to be able to expand their research and to launch into this. I thank you for your output that has also enriched me. I thank you, my PhD students. I thank you, my postdocs now. I thank you, my master students and the research team based in Kolebu who have been able to work with me over the years. Those of you who are online, also from Kenya, I thank all of you who are listening to me, Dr. Maxwell Machani, for your help in coordinating all my research. Even when I left and I wasn't there, you were able to work for this. My students who are from Tanzania, Ethiopia, Southern Sudan, Gambia, and Senegal, who have all contributed, I thank all of you who are not able to be here and listening to me. I thank you, my department, members of my department, who have pushed all of us to get to this place. In my department, we are 9 academic faculty, and 7 of us are professors. So you see how we push each other. Even one is also on the way to become a professor. And you see that we push ourselves so much to get here. Not in a bad way, but in a good way that would let us be able to move. And I thank all of you. I can't mention all of you, your names. But in particular, also, I've worked with people in this university to be able to achieve this. And so some of the work that I cannot do on my own, that is where I seek collaboration. And I would like to thank Professor Linda Eva Amwa, Noguchi Memorial Institute of Medical Research. You've been very wonderful. I thank you, Professor Gordon Awandare, Vice-Chancellor, academic affairs and students, academic and student affairs. You've been a very great collaborator in training the next generation of scientists. I thank Professor Kwejo Asamoah-Kwesi. I met you many years ago when we were graduate students, and we've worked from there. Also, Dr. Lucas Amenga Itego, we've worked for many years to produce the next people who will take over from us. From the School of Public Health and elsewhere, Professor Justice Hito, Professor Duajimo, and Dr. Fred Abuaji-Entwi, you are all listening to me. Fred is here. I thank all of you who have worked with me, and the people that I couldn't even mention their names for want of time. Internationally, it's been wonderful. And I've worked with even my own PhD and postdoc advisor as a collaborator, taking students to his lab to be able to get an opportunity to learn new methods in research. I thank you, Professor Guyanian, for allowing me, my students to come, my trainees to come to your lab. Dr. Jalen Gerardin, who was in Northwestern University in the US, and also Professor Douglas Perkins. He is the PhD advisor of Professor Gordon Awandare. And if you see Wagbik in the background, he comes to Ghana very often, and some of my students have spent time in his university working with him to gain more experience in medical research. I also talked about Dr. David Whitman. Jalen, as I mentioned, has given opportunities in Northwestern for several of my trainees to go there and get skills in disease modeling, to be able to use the data that we generate to be able to advise the Ghana National Malaria Elimination Program on how to deploy interventions. And so this, Jalen has been very instrumental in this, and I thank her. I also thank Professor Susanna Campino and Moisa Cristan from London School of School of Hygiene and Tropical Medicine for allowing my students to go to their labs to learn new skills that will be helpful in the future. And also to Dr. Courtney Murdoch from Cornell University. This is an amazing person who, when I got to know the research I'm doing, said, well, Ghana is facing the same situation like India, where I'm working. So let's go to India and see what is there. So I got a chance to work with her in India to understand the dynamics of dengue fever, how dengue and malaria coexist, and how they've been able to intervene. And this has been very helpful. Also, Professor Mariangela Bonisoni from University of Appiah in Italy, who has worked with me a lot over the years and giving me the chance to become a visiting professor in Italy. I thank Dr. Neil Lobo and Sam Rand from the University of Notre Dame. These people were able to do things I couldn't do in Ghana by sequencing or finding out what mosquitoes that when we found some of these invasive mosquitoes, we didn't have the capacity at the time to know what sort of mosquitoes that they were. So we took them there and they were able to let us know what sort of mosquito that they were. Eugenia Lowe and Toby Lehman, I'm very grateful to you for your collaboration over the years, which has helped us to see how mosquitoes travel from by long range migration. I'm grateful for you. Eugenia, you've created opportunity for my students to come to your lab to learn new skills, and I'm very grateful to you for that. Thank you for logging in to listen. And to my funders, I have been able to get funding from the National Institute of Health of the US. And this has helped me to be able to do a lot of research and to train a lot of people, develop capacity for my colleagues to use the laboratories that are in Kolebu for their research. And the Gates Foundation also, who have supported me, that within West Africa, I am able to train many people from Ghana, Nigeria, Senegal, Guinea, and Guinea-Bissau. I'm very grateful for the funding over the years. And the Natural Environment Research Council of the UK for the monies that you gave to my collaborators that I am also been able to get benefit from the Professor Sarah Rees of the University of Edinburgh. I'm very grateful for your sponsorship. And the WHO also is the one that gave me seed money to start my research in the University of Ghana before I could get all these other grants, and I'm very grateful to you. And to my family, I'm so grateful for the time that you have given me and for your encouragement to get into these areas. The encouragement that you have given to me, my sisters who are here, I'm grateful for the time that there's a lot of work that you have done that I cannot talk about it here. We'll talk about it later on. I'm glad that you were able to travel for this, my inaugural, and for my dear wife, Ajua. Thank you for the union we have and tolerating the many times that I have to leave home either to collect mosquitoes somewhere in the night or travel to report about what mosquitoes that I've caught here. And for my children also, Appiah, Amanyako, Presidako, Bakuche, I'm grateful for the fact that you understand what I do. And so when I tell you where I'm going, you are able to tolerate that. I thank you all, and I'm grateful for the opportunity to present to you today. Thank you very much.
Thank you very much, Professor Yaw Asare Afrane, for that very insightful lecture. I believe that when we leave here today, we will make sure to dispose of our old car tires and containers properly so that we do not promote the breeding of mosquitoes in our homes. And also we'll remember to desist from using pesticides and insecticides regularly so that the mosquitoes do not continue to resist these control mechanisms that we put in place. Thank you very much once again. I believe he deserves another round of applause. Thank you. And so now, to help us reflect on and appreciate what we have heard this evening, I want to invite you all to relax as we receive a performance of the Adowa dance by the Ghana Dance Ensemble. The Adowa dance is a highly expressive and graceful traditional dance of the Akan people of Ghana, which symbolizes honor, wisdom, and celebration, making it a befitting tribute to this very important academic milestone. So please help me with a round of applause. Welcome the Ghana Dance Ensemble as they perform the Adowa dance. Thank you very much, Ghana Dance Ensemble, for that beautiful performance and rich display of culture. It's now time to present gifts to our lecturer. But before we do that, please permit me to acknowledge a few personalities who are with us this evening. We have here this evening Reverend Albert Amonzim of St. Luke Catholic Church, Kolebu. Please, if you are here, would like to see you. Thank you very much for joining us. We also have with us Sister Matilda Quist from Star of the Sea Catholic Church. We are grateful for your coming. Her Ladyship, Dr. Bridget Kafui Antonio Apeji, High Court Judge. Thank you for coming. Dr. Hilarious Abiu, National Malaria Elimination Program Manager. Professor Patrick Ayekumi, former Provost of the College of Health Sciences. Professor Yaw Tete, also a former Provost of the College of Health Sciences. Thank you all for coming. Now to the presentations. First on my list, I have the College of Health Sciences, where our lecturer belongs to. College of Health Sciences, if you are here, please make your presentation. Prof, please, we ask that you move to the middle of the stage. And please, as they come up, please give them some encouragement. As College of Humanities is making the presentation, I ask the University of Ghana Medical School to get ready. Thank you very much. University of Ghana Medical School, please come up and make your presentation. As they do that, the Department of Medical Microbiology should be getting ready to also present their gifts. Department of Medical Microbiology, please get ready. Department of Medical Microbiology, we are ready to receive your gift. We kindly ask the College of Health Sciences Research Board and Research Office, Kolebu, to also get ready. College of Health Sciences Research Board and Research Office, Kolebu. As the College of Health Sciences Research Board makes their presentation, faculty trainees of Professor Yaw Afrane should also get ready. Faculty trainees of Professor Yaw Afrane, please get ready to make your presentation. As the faculty trainees are making their presentation, graduate students and research assistants of Professor Afrane should also get ready. Graduate students and research assistants, please get ready to make your presentation. Please, Prof, please move down the stairs so that we can accommodate the numbers up here. So the rest of you can climb up the stage, please. Next on the list is members of St. Luke Catholic Church, Kolebu. Members of St. Luke Catholic Church, Kolebu, please get ready. Thank you very much. Members of St. Luke Catholic Church. Members of St. Luke Catholic Church. Old students of Opokuwari School, Akatechie, please get ready to make your presentation. All students of Opokuwari School, Akatechie. Please move up the stage. All students of Opokuwari School, please move up. Next on our list is Promasidor Ghana Limited, our official beverage sponsors. Promasidor Ghana Limited. Please get ready to make your presentation. Promasidor Ghana Limited. Please help us acknowledge Promasidor Ghana Limited. They have been sponsoring our inaugural lectures and other lectures with beverage just every time. We are grateful for your contribution and your partnership. Thank you very much, Promasidor Ghana Limited. Next on the list is the extended family of Professor Yaw Afrane, the extended family. Please get ready. Thank you, Promasidor. And as the extended family mounts the stage, we ask the immediate family of Prof to also get ready. Please, the rest of you can climb up so that we can capture you all in the photograph. Thank you all very much for your presentations. For want of time, we are unable to take any more gifts. However, we have made available a gift table outside to receive any extra gifts that we are unable to call up here. So if you brought anything for Prof and we are not able to come up here, please leave it at the front desk and he will get it after the event. Thank you all very much. We are grateful. Sorry, forgive me. The immediate family of Prof, please forgive me. Sorry. My apologies. Thank you very much. I almost missed the very important part of the ceremony, the event, so please forgive me for that. We have gradually come to the end of this evening's event, and we will take the chairperson's remarks. But before that, let me make a few acknowledgements, and then the chairperson, Professor Appiah Amfo, will take over. We also have here this evening Professor Nick Monk, African University of Sheffield, UK, and also Professor Samuel Jesse, Dean School of Sciences, University of Energy and Natural Resources. Thank you very much for coming. And Honorable John Boedu, former MPP General Secretary, is also here with us. Thank you very much, sir, for coming. So please help me invite the Vice-Chancellor and Chairperson for this evening's event to deliver the closing remarks. Thank you.
Thank you very much. Thank you, Ms. Enim. And thanks for quickly correcting your mistake, because Professor Afrane, after such a lecture, should go back home peacefully. Distinguished guests, dear colleagues, curious students, family and friends of our lecturer, ladies and gentlemen, I'm sure you would agree with me that we have just experienced an engaging, enlightening, and perhaps sometimes slightly unsettling lecture. But I thank you, Prof, that you ended on a note of hope. I didn't realize that one could build decades of a successful career on this tiny insect called the mosquito. And so by the powers vested in me as Vice-Chancellor, I hereby nickname you Professor Mosquito. Professor Afrane, on behalf of University of Ghana, I thank you for a lecture that has combined scientific depth, public health relevance, and practical urgency in a truly compelling way. After tonight, I'm sure that many of us will not look at a puddle, a blocked drain, a neglected flower pot, or an old car tie left out there in quite the same dismissive way. Ladies and gentlemen, allow me to share some lessons I took from this event, from the lecture and from the lecturer as we bring this program to a close. The first lesson for me is that human activity and public health are deeply interconnected. This evening's lecture has reminded us that mosquito-borne diseases are not simply natural occurrences. Human behavior, land use changes, urban mining, urban farming, mining, we do a lot of digging, especially, with small-scale mining, deforestation, environmental pollution, and poor drainage systems all shape the ecology of disease transmission. So, yes, mosquitoes may be doing the biting all right, but sometimes we are helping to create the conditions for the biting and the subsequent diseases. And for us here in Ghana, his lecture is very timely. The rains are now upon us, with the familiar realities of flooding, stagnant water, blocked drains, and increased mosquito breeding sites across many of our communities. In moments like this, tonight's lecture moves from being simply intellectually stimulating to being practically urgent. It reminds us that public health is not only about hospitals and medicines, but also about how we manage our environment, organize our cities, and respond collectively to changing ecological realities. The second lesson for me is that nature adapts. Tonight, we have seen that mosquitoes are not passive organisms waiting to be eliminated. They adapt very quickly to insecticides, to human behavior, to environmental change, and even to our control strategies. They bite earlier, they move outdoors, they survive chemical exposure, and so on. I discovered that the mosquito can fall into a coma only to recover later to do their work. Now, the implication of this is profound. Africa cannot fight 21st century mosquito-borne diseases with entirely 20th century approaches. We must continually innovate, strengthen our surveillance, invest in science, and rethink vector control in ways that are environmentally grounded, community-based, and sustainable. He spoke about, sterilizing the male mosquito. I can only imagine how that would be done. I leave that to him and his team of experts. The third lesson for me is the importance of scholarship that directly shapes policy and practice. As we heard, Professor Afrane is extremely prolific, 136 publications and counting. But his work has not remained confined to journals and laboratories. His research has informed malaria control strategies in Ghana and beyond, contributed to surveillance systems, and guided vector control interventions across the continent. Indeed, as we heard from his profile, his scholarly journey across Ghana, Kenya, and other parts of Africa reflects the very best of Pan-African scientific engagement. His work in the Western Kenyan highlands contributed to malaria vector surveillance policies at a time when malaria epidemics were emerging as a major public health concern over there. For Ghana, the implications of his lecture are profound. It speaks directly to the work of the Ghana Health Service, the National Malaria Elimination Program, and broader disease control efforts aimed at reducing transmission and protecting communities. Beyond Ghana, the lecture carries important lessons for the sub-region and for Africa as a whole. The issues raised here are not confined by national borders. We heard about the migration of mosquitoes. Prof, what I was wondering was that who gave these mosquitoes visas to travel, and whether they have overlived their visas. Are they legal or illegal migrants? We need to find out. If they are illegal, we ought to harass them till their governments organize chartered flights for them. This may sound funny, but these issues speak to the shared challenge of our development, environmental change, and public health. As we know, intersect across our continent. It is not a problem for one specific country. It cuts across borders. And so it's important that we work together. His work reflects our commitment to our second strategic priority, which is impactful research. And we've seen that through the evidence he's provided, which directly informs policy and improves lives. It also speaks to our fourth strategic priority, engagement and partnerships, giving the strong collaboration between the university, public health institutions, international agencies, and research networks across Africa and beyond. And it also re-emphasizes our first strategic priority, which is a transformative student experience through the training and mentorship of the next generation of African scientists and public health leaders. My fourth and final lesson comes from Professor Afrane's own journey, the power of mentorship and institution building. From mentoring young African scientists to developing postgraduate programs to securing major international grants that have strengthened infrastructure and training opportunities across the continent, Professor Afrane's career reminds us that lasting academic impact goes beyond any individual achievement. It's about building people, systems, and opportunity that will endure long after you have left. Now, what is even more remarkable for me is how he got his PhD scholarship. Someone gave him the opportunity as a young scientist to present his work somewhere else. And that was his breakthrough. He has experienced good mentorship, and he's also paying forward that. So as we leave here tonight, especially in the middle of another rainy season, with the floods, the stagnant water, and so on, we are reminded that mosquito control is not only the responsibility of scientists or doctors or government agencies. This morning I heard the Greater Accra minister very angry and delivering some ultimatums. It's not only about government agencies. It's about everyday human behavior. Each of us need to be responsible. We have to be responsible for our environment. We must see this as a collective civic action. Prof. Afrane has challenged us to rethink mosquito control beyond the narrow confines of insecticides and indoor spraying. We've seen his commitment to environmental management, urban planning, sanitation systems, housing quality, and all of these. In fact, his lecture was as much about development and governance in as much as it was about mosquitoes and health. His lecture showed us that public health must be ecological as well as medical. Prevention must be community-driven as well as scientifically informed. And Africa must continue generating its own evidence to solve its own challenges. Ladies and gentlemen, tonight we have celebrated an accomplished scholar through this inaugural lecture. We have encountered scholarship that speaks directly to future health and the resilience of our continent. Prof. Afrane, we celebrate your scholarship, we celebrate your leadership, we celebrate your mentorship and your impact. Thank you for delivering so eloquently on fighting the bite, human activities, and the changing landscape of mosquito-borne disease in Africa. And as we all leave here for our homes, let's make at least 2 resolutions. One is to support science in whatever way we can, wherever we find ourselves. And the other one is very simple. Let's just check our compounds for stagnant water. That flower pot you left abandoned, that old car tie that you left there. Let's check our compound and let's rate our compounds of these. This will be our little contribution to fighting the bite. Please join me once again in congratulating our inaugural lecture. Thank you, Prof. Afrane, once again for delivering this, and thank you also for coming. We look forward to seeing you at our future events. You all should have a good evening. Thank you.
Thank you very much, Madam Vice-Chancellor, for summarizing today's lecture beautifully and also chairing this evening's event successfully. Thank you very much. Before we leave here, I'd also like to acknowledge Madam Joyce Nyakwa Abobedo and Mr. Martin Atanyame, our colleagues from the Center for Disability Studies and Advocacy, who provided sign language interpretation for this evening's lecture. Please help me acknowledge them. And also Promasidor Ghana Limited for providing the beverages for our students this evening. Thank you very much. Now to the order of refreshments. After the recession, we will host our invited guests at the north wing of the Great Hall to my left for refreshments. Our students will be refreshed at the forecourt, the AA Kwapon Quadrangle, and Promasidor is providing refreshments for them. Some of our guests can also join. There's enough to serve us all. Also, we'll take a few announcements. If you turn with me to the back page of our brochure, we have our upcoming events lined up there. Our distinguished lecturer will be hosted on Research Agenda on our campus radio station, Radio Universe 105.7 FM, on the 3rd of June at 9 o'clock a.m. We all recognize that we are unable to ask questions at this event, but on that day on radio, there will be someone who will be answering some of the questions that have been on your mind. I know that most of us have questions on our mind, and on that day, we'll have some of those questions answered. So please remember to put that on your calendar and tune in to listen. We also invite you to our UG Student Experience Conference, which takes place on the 17th of June at the City Conference Center at 8:30 a.m. We'll also convene here on the 25th of June 2026 for another inaugural lecture, which will be delivered by Professor Enes Kenu from the Department of Epidemiology and Disease Control, School of Public Health, also at the College of Health Sciences. And he's delivering on the topic, Disease Smuggling, the Unseen Cargo in Global Health Security, Lessons from Cholera and COVID-19. I know that we are all interested in COVID-19. We want to know how far COVID has gone. Is it still with us or has it left us? So please remember to join us on the 25th for this lecture. Thank you very much. Now I'll go to the order of recession. After the university anthem, the platform party will recess, and then our guests can follow. So please, we'll be upstanding, and then we'll allow the platform party to move out before we do. Thank you all very much. We wish you a very good evening, and we look forward to see you at our upcoming events. We are grateful for your time and for joining us this evening. Please rise for the university anthem.
Power of many, is my young and old.
Thank you very much. Ghana Dance Ensemble. Please, before we leave, someone dropped their bracelet, so if you've lost a bracelet, please see me and pick it up. Thank you. You found the bracelet.